of all, again, I'm going to teach you how you can import data. Again, good afternoon for those students that come to class late. So today we are going to have a workshop about EViews and JASP. So the first software that you are going to learn about it is EView. First of all, import your data. Go to File, Import, and then find the related file. So download. Now I'm going to do the regression. Go to Quick, estimate equation, estimate your function, estimate function. So to estimate function, first you need to write down your dependent variable, So first write dependent variable. GDP is our dependent variable. For intercept, you need to put C for intercept, for alpha. Don't assign the name C for private consumption, because by default defined for software that C always is intercept. So don't put C for private consumption. So GDP C, private consumption and investment. I have two independent variables, So GDP C, PC, IN. GDP C for intercept, PC is the first, and IN is the second independent variable. And then you can do the regression and get the result here. So again, copy whatever you have here and paste it. So all coefficients are significant because p-value is less than 5%. P-value is less than 5%. So there is a meaningful relationship between private consumption and GDP and investment and GDP, because p-value is less than 5%. So we can reject the null hypothesis. So it means there is a significant positive relationship between private consumption and GDP, and there is a positive significant, it's negative relationship between IN and GDP, which is not meaningful, because we know there's a positive relationship between investment and GDP. So we need to check our data later. We need to check diagnostic tests. Sometimes we have a diagnostic problem like multicollinearity, heteroscedasticity, and autocorrelation. So instead of find positive relationship between investment and GDP, we got negative relationship, which is meaningless. We should have positive relationship. However, is a result of the first function. After you do the regression, you need to find a diagnostic test. So how you can find a diagnostic test? You should go to View, Residual Diagnostic, and then we have a heteroscedasticity, autocorrelation, normality test, and different type of the diagnostic test. So suppose if I choose this one, heteroscedasticity test, you can find many different type of tests like the Harvey, Gleiser, Arch, White, so on and so forth. So the most famous one is the White test. So if you choose the White test, you're going to get this result. So I'm going to make copy of White test, and paste it here. So White test result shows that p-value is less than 5%. So we should reject the null hypothesis. It means we have problem of the heteroscedasticity. It means our variance is very, very big. Therefore, the impact of heteroscedasticity has a negative influence on result of our test. So we should fix the problem of the heteroscedasticity. One of the way that you can fix the problem of the heteroscedasticity is take the logarithm, ln. So again, I'm going to rewrite the first function. This round, I'm going to put ln. You should check here, p-value, you see, in the front of f-test, p-value of f-test is 0.0010 is less than 5%, and the chi-square test is 0.0021. So you need to check these two p-value. So both of them is less than 5%. So when less than 5%, you should reject the null hypothesis. Means error variance is heteroscedastic. So it means we have problem of the heteroscedasticity.
Should we examine data analysis part?
Data analysis is one part. Another part, maybe you have your function is not a good function for estimation. You need to define another method or function for your estimation. So wait, I finish this one, then you will figure out. Okay. So one of the things that you can do to fix the problem of the heteroscedasticity is to take ln. Take ln. Okay, how we can take ln? So let me first check another diagnostic problem. Another diagnostic problem is serial correlation, or they call it autocorrelation. For autocorrelation, you need to define the lag length. So we are going to define two lag lengths. This one is by default chosen by software. So we put two lag, okay? And then here also, we got the BG test. BG test. BG test. So BG test result are here. So to check whether we have problem of autocorrelation, again, you need to check the p-value of f-test and chi-square. So p-value of f-test and chi-square is 0.0000. It means, again, we reject the null hypothesis. We have problem of the autocorrelation. So in this regression, we have two main problems. We have problem of the autocorrelation and heteroscedasticity. That's why when we got the result, we found a negative relationship between investment and GDP, which is meaningless. Why? Because when we have problem of the diagnostic like heteroscedasticity, autocorrelation, you cannot get accurate, decent value for your variables. So again, how to find your problem? You need to check p-value of f-test and chi-square. If p-value is less than 5%, we cannot accept the null hypothesis. We should accept the alternative hypothesis, and based on the alternative hypothesis, we have problem of the autocorrelation. Okay, so what can we do for heteroscedasticity, and what can we do for autocorrelation? One of the solution for heteroscedasticity is to take logarithm from all variables. So it means for GDP, for investment, for PC, we should take log. How? Go to command part, write the formula. To take log, you need to use the command of the EView. The command is GENR. GENR stands for generate. We give this order to software, generate something. What we want to be generated? We want to have LGDP. L, it means logarithm of the GDP. So the software asks us, what's the meaning of LGDP? We should define for software. So we should define LGDP means log of GDP. Log of GDP. So we give this information to software. Okay, we need LGDP. L stands for what? Log of GDP. And then enter. So when you enter, So LGDP pops up here. See? This one is LGDP now. Yes. Command is here. So you should have one table on top of your software. Show me your desktop. Yes, here. General, LGDP equal log GDP. So for PC, do the same. ln PC log PC. So we ask software to generate logarithm of PC, private consumption, and then enter. Don't forget, you need to enter. LPC, where's LPC? LPC is here now. LPC is here. And then third, again, for investment, you need to do the same. LIN log IN. So you give this order to software. Now I want to have ln of investment. So generate LIN. LIN means log of IN and then enter. LPC, LIN. So now we have LIN, LPC, and then LGDP. Bear in your mind, you cannot take log from negative and percentage value. From negative and percentage value. If you have percentage, for example, if you have interest rate, you cannot take log. If you have negative value in your time series, you cannot take log. So your value should be positive. And of course, you cannot take log from the negative value. So go to quick for second regression. Now we have a new regression. In this new regression, we have LGDP, equal, of course, I don't write the intercept because you can write the intercept if you want. Instead of this one, you can put, for example, A plus B, L. B is a coefficient of the correlation between PC and GDP. And so this one is B1, LPC, and then B2, LIN, investment. Okay, now we have second, so this one was our first regression, simple regressions. I took log from all variables, LGDP, LPC, LIN. So now we have ln of all variable. Again, go to quick, estimate, quick estimate. So first write your dependent variable. Dependent variable is LGDP. So LGDP is here. Then put C for intercept. Put C for intercept or alpha that you have in your regression. And then write down your independent variable. The first independent variable is PC, LPC, and the second is LIN. Okay? LPC, LIN. LPC, LIN. and then do the regression. Yes. So I got new regression, all variable now in the ln form. Copy. Copy. Paste. So I got the result of ln. So again, you need to check the diagnostic problem. Go to view, find the residual diagnostic, and then use the heteroscedasticity test, white test, heteroscedasticity test again. View, residual heteroscedasticity, white test. Okay. So now you solve the problem at 10%. At 10%, you solve the problem. It means if you consider 10% as your criteria, not 5%, now you resolve the problem just by take ln. So by default, if you take ln from your variable, to some extent, you can reduce the impact of variance. So I do recommend, if you want to use the secondary data, it's better you take log. But bear in your mind, you cannot take log from negative and percentage values. Okay, so at 10%, we solve the problem. Again, you need to check p-value, and p-value of the f-test and p-value of chi-score is 0.02. Is not significant at is not significant at 10%, but significant at 5%. So it depends. You want to consider 5% or 10% as your index of the comparison. If I consider 10%, it means we cannot reject the null hypothesis. It means error variance is homoscedastic. It means we resolve the problem. But if you check 5%, again, we have problem of the heteroscedasticity. However, if we compare the first table and second table result, we will figure out that to some extent we succeed to reduce the impact of the heteroscedasticity. Okay, the second problem that we faced here initially in this part is problem of the autocorrelation. So do we have problem of the autocorrelation? Let's see. Go to view, serial correlation. Again, you need to put by default 2 lag lengths for the LM test. Yes, unfortunately, still we have problem of the autocorrelation. So take log is a good solution for heteroscedasticity, but is not good solution for autocorrelation. So what should we do? As I mentioned earlier, to resolve the problem of the autocorrelation, it's better that you use the first difference. Use the first difference. So again, so let me copy this one, and paste it here. Paste it here. So we have a still problem of autocorrelation. So what should we do? We need to take the, we need to use the first difference solution. You need to use delta. Let me find delta, should be here. Where is delta? Okay, delta GDP. Delta GDP means GDP at T minus GDP T minus 1. So it means if you want to find delta GDP between 2022 and 2021, you should find GDP of 2022 minus GDP of 2021 to get delta GDP. So delta GDP is one of the main solutions. Find the first difference is one of the main solutions to resolve the problem of the autocorrelation. So delta GDP So I'm going to define the third function, delta GDP, delta PC minus, plus delta IN. So I define the third function. So again, for those students that came to class late, first I define the simple function. When I use the simple function, I found the problem of the heteroscedasticity and autocorrelation. After that, I take log to reduce the problem of heteroscedasticity. After I took log, I resolve the problem of the heteroscedasticity. Now this one is in order to solve the problem of the autocorrelation, I use the first difference. Delta GDP equal delta PC and delta IN. So how to define the delta for software? Again, go to command section. Use generate. Generate what? We need to have D for delta. So we need to have D GDP. D GDP. Generate D GDP. D stands for delta. DGDP means D parenthesis GDP. So I define for software that what's the meaning of the delta GDP? Delta GDP means DGDP. Take the first difference between current value and the previous value, and then enter. So DGDP appear here. So DGDP pops up, and then you can compare value of the DGDP with GDP. So this one is GDP, this one is DGDP. So 1,278 minus 10,278 minus 10,031 is 247. Am I right? 10,278 minus 10,031 is 247. For the first, we don't have any value because we don't value of 2025, for example. Still, we are in 2024. So for the first observation, we don't have any value. For the second is the difference between this one and this one. 10,357 minus 10,278 is 79. Am I right? So you can find the first difference. For other variable that you have in your regression, do the same. Again, go to command part. D PC is DPC. And then enter. So DPC pops up. And then for IN, do the same. IN IN. Okay, we have DPC, DIN, and DGDP. DPC, DIN, DGDP. So do the regression, go to quick estimation, and then list your IV and DV, dependent and independent variable in your functions. So the first variable that we have is D, GDP, DGDP. The second variable is C, intercept, DIN, and then finally DPC. Let's see how is the result. So DGDP, C, DIN, C, DPC. C, DPC. Okay, now see the result. Investment is not negative anymore. Now investment is positive. Consumption is positive. All coefficients are significant. Copy your result and paste it. Paste it here. Paste here. So our target is to find whether the problem of autocorrelation is fixed or not. So again, you need to go to quick. Sorry, yes. You need to go to view, residual diagnostic, serial correlation LM test. By default, 2 lag. Bingo. Problem resolved. Now, if you copy, paste it. So what happened? Now again, you need to check F value and chi value, P value. For both of them, it's greater than 5%. So it means you cannot reject the null hypothesis. It means we succeeded to resolve the problem of the autocorrelation as well. That's why it's good that you use those methods, those models that they use first difference, like what? Like ARDL. ARDL by default employed the first difference approach in the estimations. So for those students that they want to do the secondary data, I do recommend that you use ARDL. If ARDL is difficult for you, you need to follow this procedure. It means you need to first write down the original function, original OLS, original OLS method, then check the diagnostic problem like heteroscedasticity, autocorrelation. Then I do recommend you take the log for all variable except percentage and negative value. Again, check heteroscedasticity and autocorrelation. And if the problem is still there, I do recommend that you take first difference, delta, and do the regression. So based on this regression, I resolved the problem of the coefficient as well. Last time, we had negative value for investment. Now we have positive value, and it is very, very gorgeous result because this one is 0.87, this one is 0.83, this one is 74. Last time, intercept negative and was very big. Let's see. Last time, intercept was minus 1,000, am I right? 11,837. And negative, which is not good. And investment was negative as well, which we expect to see the positive relationship between I and investment and GDP. Now, after we took the first difference, we got positive value for both consumption and investment, and of course, private consumption. And then all coefficients are significant. And then we succeeded to resolve the problem of the autocorrelation as well. So it's a very, very good example for finance student, and those students are interested to use the secondary data for regression. So I review last sessions, but I give a detailed information. And this round I record this session. So later you have access to the video of this session. Oh, it's good that all of you have it. The link provided through the email, you can find it. I already sent an email to all of you. You can find it. So I give you 10 minutes break, and then second session, I'm going to work with the JASP software. We have 10 minutes, and then we continue. Don't forget that sign the attendance for 2 sessions. Thank you. Okay, guys, the first I forgot these important things. For EViews and for JASP, the first important thing that you need to put in your result is descriptive statistic. So for descriptive statistic, suppose I want to find the descriptive statistic of these three important variables: GDP, investment, and private consumption. Use control and take all this variable. Right click, open as group. GDP, IN, and PC. Private consumption, investment, and GDP as group. As group. Okay. Find descriptive statistic. Where is it? Descriptive statistic. So for those students that they use the secondary data, the first important table they should put is descriptive statistic. So common sample, yes, this one is a descriptive statistic which shows mean value, maximum, minimum, standard deviations, screeners, kurtosis, Jack-Bra, probability, sum, whatever. So copy again, copy, and paste it. So the first important table is this one, descriptive statistic. I don't recommend that you use table of EViews for your assignment. It's good that you have separate table, summarize your result, extract your result, and then set up new tables and put all EView in appendix of your work. Okay, so if you want to use the EView table, it's very messy. It's better that you summarize result and then put all the EView tables in appendix. Okay, any question about the OLS, LN, and the first difference? Any question? Okay. If you don't have any question, we jump to the second part. Yes. Yes, what's your question? Delta, yes. Yes. So as I mentioned, it's better first you do the OLS. Okay, follow all these steps. And then after that, get these conclusions that, okay, because I face this type of problem, I'm going to use VAR or VECM or gradual test for my regressions. So it means this result is our justification for using the VAR. Okay, okay, second software is JASP. It's free, it's good. Again, I do recommend that you use SPSS because I'm not rich enough to buy the SPSS, so I use this JASP. JASP is the software that's created by the University of Amsterdam. It's free of charge, any charges, so you can use it for the live download link is provided. Have you already downloaded the software, all of you? Okay. So free, friendly, flexible. Okay. For this software, I put this data on your Moodle. You can find it, data 4, data 5, and data 6. So I use data 1 and 2 for secondary data, 4, 5, 6 for primary. Also, we have some kind of secondary data here in some of them. So download this fancy way is about AI. You have some question here. Okay, this one. Perception analysis for the usage of AI in HR. So it's So maybe 10 questions. Just I use this simple survey to show you how you can import data from Excel to JASP. Okay, the kind of question that we have here: age, write a number. Sex, male, female, prefer not to say. What type is your company organization? Option 1, corporation, government, so on and so forth. Question number 4, how long have you been working in the HR? Question 5, have you been in any other department except HR? Option 1, yes. Option 2, no. Question number 6, if yes, what department? Now, this one is the general or demographic question that you have in your questionnaire as well. And second part is about the AI impacts. Question number 1, does your company organization use AI in the human resource management? Option 1, yes. Option 2, no. If no, please skip all questions. So it means this survey is not useful for you. Option 2, if yes, since when has company organization started to use AI in HR? Question number 3. Question number 3, at what capacity does your company organization employ artificial intelligence in the human resource management? Option 1, recruitment. Option 2, employment assessment. To option 8. 4, how do you feel about the statement, use of AI in HR increases productivity, efficiency? Option 1, strongly agree. 2, agree. 3, indifference. 4, disagree. 5, strongly disagree. So it's based on the Likert scale. You have 5 options in one question. Strongly agree to strongly disagree. Question number 5, how do you feel about the statement, use of AI in HR reduce operational cost? Again, option 1, strongly agree. To option 5, strongly disagree. Question number 6, how do you feel about the statement, AI will replace humans in the workplace? It's a serious question, huh? Option 1, strongly agree. To option 5, strongly disagree. Question number 7, do you think AI and human can be part of the same workforce? Option 1, yes. Option 2, no. Option 3, not sure. Question number 8, do you fear your job will be replaced by? Again, option 1, yes. Option 2, no. Very good survey, huh? Because you can use it to evaluate the impact of AI in HR. So I refer you to model, download the data for. So data has been collected based on answer of the 10 respondents. So for your study, you can use the pilot test, at least 30 to 40 respond. But here just we have 10 respond. So we have gender, type of organization, durations, how many years, place, which department, capacity, productivity, impact of AI, and performance, which I just put productivity. For efficiency, I put AI reduces cost. For replace human, I define this one. And is it possible that we can use both of them simultaneously? They can have both AI and human. So this one for AI replace. And the last one is a fear. So we have this survey question. Now I want to import data. Go to JASP. Open computer. Open computer. Where is it? Data 4. Are you with me? Yes? So you can find your data here. 1, 2, 3, 4, 5. Okay, first of all, you can change number to factor that you have in your survey. For example, we have gender. Double click. If you double click on this variable gender, then you have different option: ordinal, scale, nominal. This one is ordinal. Instead of 1, 2, 3, you can write the name of them, put a label on them. So 1 for male, 2 for female, and 3 for what we have in our prefer not to say. Prefer not to say. See, the gender now is written based on the male, female, male, male, prefer not to say, female, male, female. Or type of organization that we have. Again, double click on type of organization. We have label of 4 organization, 1, 2, 6, 10. So 1 stands for what? 1 is corporation. Two for government. So then we have 6 international organization, and 10 is educational institution. Okay, so you can change the name whatever you want to. Of course, it's not whatever. You should put a name based on whatever you have in your survey. So it's up to you. Now I just write down the name of this. I put a label for this organization, so on and so. So it's up to you. Okay, the second important thing is the descriptions. Descriptions. So again, we have, if you want to have description of all your variables, take all of them, Control A. And drag them and put them here, just drag. And then result pops up, pops over. You can find the result, descriptive statistic. Again, as I mentioned earlier, you should have descriptive statistic. Descriptive statistic. So to copy paste Just click here, copy, and then paste it. Of course, you can change the font and make it nice, huh? Something like this. Valid, mean, oh. Descriptive statistic. Don't forget, you should have descriptive statistic. The first important table that you need to put, you need to find is the descriptive statistic. Okay. So you can change the content of the descriptive statistic based on information that you want to add to your table. For example, we have valid, missing, mean. Suppose I want to add skewness and kurtosis. So skewness and kurtosis appear here. Or if I want to have, I don't want, for example, minimum. So the minimum is not here anymore. Or if I want to define the confidence interval to me. So I have new column here for confidence interval. Or if I want to have confidence interval for standard deviations. Or if I want to put confidence interval for variance. So that's why software is friendly, huh? It's easy to find different aspects of the descriptive statistic. Basic plot. Okay, if you want to have a pie chart, bar chart appear here. Just copy it and use it. So for gender, 20 to 40 female and 60 to 80 male. Type of organization, duration, place, capacity, productivity. Okay. Or if you want to have a Likert plot, automatically you have it. You should give some time to your software. This one for Likert plot. Again, copy, paste it. Need to adjust it now. So if you define your variable, if you define your variable initially in a state of number, you're going to give the name, because I didn't define it. For male and female, I defined. for organization, I defined. For other variables, I didn't. So if you want to have description here, you should define your variables. Okay, so this one for a scatter plot, if you want to have a scatter plot. Scatter, yeah, this one is a scatter. See, it's gorgeous, huh? This part is a scatter plot. Table. If you want to have a frequency table, you are going to get new table. Oh, this one is for frequency tables. Okay. It's a general information about how to show the descriptive statistic of your questionnaire or survey. So you should have this part first. And it's not difficult, but if you use this software, it's easy to summarize all these results. Just you need to copy and paste. Copy and paste, that's all. Question? No question? Okay. Close everything. Say goodbye to AI. Open again JASP. Download data. Data 6. One important thing is about JASP. Your Excel file that should have this extension CSV, otherwise you cannot open it. Make sure that if your Excel file doesn't have this extension, then you need to change it to CSV. CSV. Okay, data. Mm, 5. No. You want to start with data 6. Download data 6. 6. Yeah. Okay, now this part is relevant to EViews student. We want to find the relationship between job satisfaction, then burnout, and turnover intention. So how is the relationship? What's the meaning of burnout? Burnout means you are frustrated. You don't like your job. You got exhausted. Huh? So how's the relationship between burnout and job satisfaction? Positive, negative? Negative. If you're not happy, you don't like to work. How is the relationship between turnover intention? What's the meaning of turnover? Turnover means, yes, if the employer want to fire employees, turnover intention. How is the relationship? Negative, positive? If you think that if you think that there is a possibility of leaving the workplace, so how is the relationship between job satisfaction and turnover intentions? The relationship is negative. That's right. So by default, we should have these two negative relationship. Am I right? Yes? IBU student? Okay, so this, the previous example for e-commerce, the impact of IB, the first example for finance student, and this one for IBU student, job satisfactions. Okay, if you check this data set, you can find GS for just job satisfaction, BO for burnout, and TOA is turnover intentions. So we have these three variables. Of course, we have other variables, but I want to use just these two important variables. And then how many observations we have? We have 200. So this data is based on the 200 respondent answers. So 200, GS, BO, TO. Again, you can take all these variable and drag to the right side, right tables. Just I use the three main variables, GS, BO, GS, BO, and TO. Yeah, this information's about these three important variables. A statistic, I think the information is enough, but maybe I want to use the pie chart for this example. So it's not possible because we have a 200, so we cannot get this one. How about the liquor? Liquor is not possible because it's not a scale. This one is not a scale variables. Anyway, okay, I want to use it for regression. Go to the regression. I want to find the correlation and regression between these three variables. Go to correlation first. So first of all, I want to find the correlation between GS, job satisfaction, and BO, burnout. So this table is the table shows Pearson correlation. Pearson correlation can be used for validity test because to some extent you can find the correlation between your variables. So Pearson value is minus 0.65, which is based on our expectation because we already have this impression by default. There is a negative relationship between burnout and job satisfaction, and we got minus 0.650. So our value shows that based on the Pearson correlation, there is a negative relationship between these two variables. And how about this one? How about so instead of B, I return B to the initial table, and then I just drag this one, TOI here. And then for TOI also, I got the negative relationship, which is based on our expectation. So this one, again, negative relationship between these two variables. And p-value also is less than 5%. It means significant. Significant. Okay. But if you want detailed information, this Pearson cannot give us the, of course, we have other type of tests like experiment and Kendall. So in your table, you can get information of these two tests as well, and the results are consistent for experiment and Kendall. We also got negative relationship. Okay. So we can use this one for validity as well. Pearson test and result confirmed when we use experiment and Campbell. Okay, but this information is not enough for us. We want to find alpha, beta for the regression. We want to do the multivariate, multiply regression. Therefore, instead of correlation, you should take the second option, linear regression. If you use linear regression, first of all, you need to define your dependent variable. So GS or dependent variable. And I want to analyze the relationship between GS, burnout, and turnover intention. So covariate is for BO and for tolerance. So the result pops up here. The first table is ANOVA table. ANOVA. Copy. Copy. Copy paste. Copy paste. So we have ANOVA information. For ANOVA, we got significant relationship. So it means overall relationship between dependent and independent variable is significant. F value is 165 and P value less than 5%. So overall relationship between IV and DV is significant. So F test. But we need to find T value. We need to find T value and intercept. So we have H0 and H1. H0 means there is no relationship between each independent variable and dependent variable. H1 means there is a significant relationship between dependent and independent variable. So H1 for intercept is significant. For BO, beta 1 is significant and negative. For TOI is significant and negative. You can copy and paste one, or you have add note. I want to utilize this option today here now. I want to write down the formula here. for you. So the dependent variable is GS, that's right. GS equal, intercept is positive 215.067 minus, because I got negative value, 1.031 BO, which is my first independent variable. Then we have, negative again, minus 2.508. This variable is TOI. Okay. So I utilize the add note option of the software as well to write down the formula. And both of them are significant. Most of them are significant. And bold it. You can add video or whatever. So it's a very good and friendly software. Okay, you can utilize this option as well. A statistic. Okay. We have diagnostic test. For example, if you want to find the Durbin-Watson, which stands for, which employs for autocorrelation, you can find Durbin-Watson here. The Durbin-Watson information given. So Durbin-Watson for the first, Durbin-Watson is 2.289, which is close to 2. So it means we don't have problem of the autocorrelations. If the value of Durbin-Watson close to 2, it means no, we don't have problem. If close to 1 and 3, it means we have problem of the autocorrelation. So based on this information that you can copy and paste it, you can get information of the Durbin-Watson test. So let me take this one for Durbin-Watson, copy and paste one for the main result. Yeah, Durbin-Watson information. You can make Durbin-Watson information, coefficient that you have for your regression. It's good that you can also add value or delete something from table. P-value significant for all coefficient. Yes. P-value significant. P-value significant. Can I make it copy? Yeah, let's see. No, it's not possible. Okay, never mind. Okay. If you want to find the residual histogram to find the normality test, you can use this option. So we have normal distribution, very good. This one is normal distribution. It has normal distribution. We have the graph shows that we have a symmetrical graph. It means we have a normal distributions. And then if you want to get the residual dependent, you can get the residual dependent information. If you want to have residual independent, You can get the residual independent table. So when you check the residual independent, there is no systematic pattern. If you have systematic pattern, it's a sign of autocorrelation. Here we don't have systematic pattern. We cannot write positive and negative relationships. So it's okay. It's very good. I like this one. Okay. And then let's see what we have here, what we can add to our table. Q and Q table. This one is Q and Q table. Partial plot, if you want to have partial. Okay, so this one is a multivariate regression. Question? Hmm? Yes. You need to have descriptive statistic. This one, the first table that you need to put is this one, descriptive statistic. No. But of course, you can make your assignment beautiful, huh? To give this information about diagnostic tests like the Darwin-Watson test, autocorrelation. Of course, you need to have information about the validity and normality. Validity and normality. Pearson can be used for validity test, and I'm going to employ the next data to show the reliability test, Cronbach test. Okay, any question about this part? The most important, yes, and of course, you need to have a hypothesis testing. Hypothesis testing. Or, okay, which part? Multicollinearity, you mean? Of course, reliability and the Pearson test give you information about the multicollinearity and the validity and other things. Okay, of course, you need to have, yes. No. Okay, guys, say goodbye to this one. Okay, and open new one. JASP. This one, the okay, it's better we have 10 minutes break and then we continue. 10 to 15 minutes break. I got tired, huh? Okay, guys, we resume our session with we proceed with this data set, data 5. Open computer was data 5. Yes, it's a quite similar to your project because it's based on the questionnaire, but I don't have any idea about the different question of this questionnaire. Just I want to utilize this questionnaire information. We have 117 respondents, and we have a 20 scale. It means roughly we should have 20 questions in this questionnaire because we have 20 scale. And then the dependent variable is sum scale here. Again, descriptive statistic. Take all variable. Okay, we have descriptive statistic. The valid is 117. We have 117 respondent. Missing, no missing. It means we have data of all respondents. We have mean, standard deviations, minimum, maximum. Again, you can define, you can drive the basic plot based on each scale that you have. It's good for you for your questionnaire. You know, for example, if you have 20 questions, you can find a pie chart of each question. It gives you extra information about the distributions of the response that you have in your question. As I mentioned, for your assignment, all tables and figures are excluded from word count. So you can put all these figure if you like. But definitely you need to have this table, descriptive statistic. Again, we have regression here, correlation. So if you want to find the correlation between all scales, suppose that you want to find the correlation between all scales. For example, you have 20 questions in your questionnaire, then you want to find, is there any significant relationship between your question you have in your questionnaire or not? So take all of them. You have 20 scale. I want to use all these 20 scale. So the Pearson table is very good. I do recommend that you have this table in your assignment. And then then you can add some ingredient to your option, to your table. What's the ingredient? For example, you can use the flag significant correlation. If you use flag significant correlation, you can find which coefficients are significant. If you put flag, see here, you can find which of you can find those significant coefficients. This one is significant at 5%. Let me copy and paste this one. Copy. Where is it? paste. If I change the font, let's see how can I get the result. Time 8 6. Okay, so anyway, let me see if I took the again, double check. Okay, this one is the Pearson result. You can check one by one and see which coefficients, find those significant coefficients. So we have 20 scale. And you can find significant coefficient. 3 star stands for significant at 1%. 2 star stands for significant at 5%. 1 star stands for significant at 10%. So for example, this one is not significant, see, because we don't have any star. But this one is significant because we have 3 star. It means significant at 1%. This one is a 1 star, significant at 10%. 1 star, significant at 10%. This one is insignificant. It means there is no correlation between a scale 3 and a scale 8. Not significant. Then this one is not significant. There is no correlation between a scale 17 and a scale 4. Scale 17, this one is 17, and this one is 4. There is no no correlation between a scale 10 and a scale 4. However, for example, if you want to find, is there any significant relationship between 3 questions which relevant to one independent variable, just you can do the Pearson for 3 scales. Suppose just you want to okay. So suppose just you want to find how is the correlation between these 3 scales. So this table, it pops up. This one. Pearson correlation shows the correlations between 3 scales, which maybe these 3 scales relevant to one independent variable. All of them are significant. Okay, so the last part of this video is about the reliability test, which is useful for you, for your project. So there is no option for reliability test, but there is one plus here. if you click here, you can add some option to your framework. So we have many options. For example, we have even machine learning. We have machine learning here. So find reliability, this one is machine learning. So find, reliability is here. Have you found it? Reliability, and then magic. Reliability is here. Wow. You can find reliability. 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 And then click on reliability. Okay. Reliability test. So we have 20 scale. We want to find the reliability of these 20 scales. Again, take all of them. Okay, this one is a McDonald Omega. McDonald Omega. But we normally we like to find Korenbach or Korenbach test. So this one is a Korenbach. See? It's a result of the Korenbach. So you can use this one for reliability test of your model. So it's 0.21, which is not a good number, should be above 70%, for Korenbach test. So this one, McDonald Omega, Korenbach, all of them are different type of the. So we have Galtman. So these tests are different type of the test of the reliability. Okay, this software has a very good option. This software gives you information. If you drop which scale, you can get better reliability. On the right side, for example, if you use this one, this option, Korenbach alpha, if item drop, which item, if we drop, we can get better Korenbach. So you are going to get this table. If we drop a scale 1, our Korenbach is 0.21. If we drop a scale 2, our Korenbach is 0.28. So if we get high value here, it means we should drop that scale. It means that scale is going to deteriorate or resolve. We should drop that one. It's very, very fruitful, useful information. So in this way, you can find different tests for reliability. And then now you have many options here you can utilize for your test. Okay, today I explained briefly 2 software. The first software was EViews and the second one was JASP. If anyone want to use this video later, you need the permission of Dr. Sayed. Strictly prohibited using without the permissions of Dr. Sayed. For those students want to use it next semesters. Thank you so much.